Assalamualaikum and good evening everyone. We are from Group 5C and today we would like to present our project titled Molecular Symmetry, which is a part of our coursework for SKT 3013 in Organic Chemistry. So let us begin by introducing our group members. Introduce the members of our group. So our group consists of 4 members including me. So my name is Nurwaida binti Mahmud. You guys can call me Wawa. And then my friend her name is Nur Batusha Balkis binti Muhammad Beki. You guys can call her Isha. And then Nur Kairunisa Akmal binti Hanafia. You guys can call her Nisa. And finally Nur Shafika binti Cik Ibrahim, which you guys can call her Pika. So before we diving into a theory, let's take a moment to recognize how symmetry exists all around us, which is in nature, architecture, art, and even in our own bodies. So this natural balance and repetition play an important role not only in aesthetic but also in scientific understanding, especially in a chemistry when we study a molecular structure. So what is symmetry? Symmetry is defined as a proportionate and a balanced similarity that is found in two halves of an object. In molecules, symmetry describes how a molecule can be transformed and still look exactly the same. This transformation can include rotation, reflection, or inversion. There are two key terms we must understand. The first one is symmetry element and the second one is symmetry operation. Symmetry element is a symmetry operation which carry out with respect to lines, point, or plane, while symmetry operation is an operation performed on an object which leave it in a configuration that is indistinguishable from and superimposable on the original configuration. There are 5 examples of symmetry element and operation, which are identity, E, and full axis of rotation, Cn, in full improper rotation, Sn, plane of symmetry, sigma, and the center of symmetry, which is I. After identifying the symmetry element in the molecule, we can classify it into a point of group. So what is point of group? A point group is a set of symmetry operations that describe all the symmetrical features of a molecule. It helps us categorize molecules based on their shape and symmetry. So this mind map can help us to identify the point group of the molecules much easier. Point group can be identified based on 4 phases. So the phase 1 is a group with low symmetry, which is C1, Cs, and Ci. As for phase 2 is a group with an N full rotational, which is Cn, Cn horizontal, and Cn vertical. For phase 3 is a dihedral group, which is Dn, Dn horizontal, and Dn diagonal. As for phase 4, which is a group with a high symmetry, for example is T diagonal, T, O horizontal, O, I horizontal, D infinity horizontal, and C infinity vertical.
Let's proceed for the phase 1, which is observations of the real object that has been selected. That's the fan show a symmetry. Yes, the fan is a symmetry. The plates are arranged evenly around the center and the overall shape is balanced. Line of symmetry. This fan has more than one line of symmetry. Since it has 5 plates, we can draw 5 imaginary lines from the center through each plate, dividing the fan into an equal part. They are called line of symmetry. This fan also has a plane of symmetry. The fan also has one main plane of symmetry. That is a horizontal plane. The horizontal plane that cut through the middle of the fan, dividing it into a top and a bottom part that are symmetric. That's all for the phase 1. Let's answer the quiz. Try yourself.
So next, we are going to look on phase 2, which is physical model.
So this is our physical model. As you can see, its name is trans-dichlorobaside ethylene cobalt 3. And you can also see as the picture and its formula itself.
Hi everyone, I'm Nisha and today I am going to talk about our infographic. So let's get started. First, I will explain what is included in our infographic. In our infographic, highlight the concept of symmetry operation, the point group of molecule we choose, and there's even a QR quiz to test your knowledge. Sound exciting, right? So let me walk you through everything step by step. Let's begin with symmetry operation. A symmetry operation is an action performed on an object that results in a configuration that is indistinguishable from and superimposable on the original. Next is the point group. A point group is a set of symmetry operations that leave at least one point in a molecule unchanged. These include rotation, reflection, inversion, or improper rotations, and the point group describes all possible symmetry elements for a molecule or object. Now, let's move on the analysis part of our infographic. So that we use a flow of yes or no question to determine the point group of the molecule. First, is the molecule linear? The answer is no. So we know it's not in a linear point group. Then we ask, does this molecule have DD, sigma hash, or inversion horizontal symmetry? The answer is also no. So we can rule out those high symmetry group. Next, we check, is there a principal CN axis? And the answer is yes, which means the molecule has rotational symmetry. Then, are the CN axis perpendicular to the principal axis? The answer is again yes, showing that it has more than one axis of rotation. After that, we ask, is there a horizontal mirror perpendicular to the CN axis? The answer is no. So it does not belong to the DNH group. Finally, are there any vertical mirror planes contain the CN axis? The answer is no as well. So, based on this flow, we determine that the molecule belongs to the D2 point group. And if you want to test your understanding, you can scan the QR code below to try our quiz. That's all for me. Thank you.
So in conclusion, symmetry is a fundamental concept in chemistry that helps us understand molecular structure, physical properties, and chemical behavior. So through this project, we not only identify symmetry in everyday surrounding, but also learn how to apply symmetry operation and assign a point group to a molecule. So we hope this presentation has given you a clearer view of how symmetry play a vital role in inorganic chemistry. So thank you for your attention. Bye everyone.